Good morning, everyone, and welcome to Autodesk Virtual Academy, brought to you by Cative Technologies. I really want to be like a 50s radio host. That sounds so fun.
You're on the way, Nigel. You're on the way.
Let's do the time travel. If anyone knows how, let me know. So, welcome to Autodesk Virtual Academy, your one-stop shop, I guess, for all things product design and manufacturing collection, even things that are outside of that. Today, we're going to be going over something I think that's really important is what's new in HSM 2019.2.
Mm-hmm.
And for those of you who don't know what that is, HSM stands for
High-speed machining,
which is the CAM portion that installs right on top of your Inventor installation, so that you can do your machining right on top of your Inventor models without having to export it to something like a master CAM,
right,
or just another software in general. So Alex is going to go over the new things included in HSM 2019.2. This came out a couple months ago, I think, before the end of the year.
Yeah, I believe 2 months ago. Early November, mid-November, somewhere around there.
Yeah, so for those of you who haven't installed it yet, definitely be on the lookout for that in your desktop application. And if you haven't, started installing Inventor 2019 yet, it came out in April.
Yeah,
so
it's been out for a while.
Yeah, for those of you who need help with that, let us know. We can help you get squared away. So like every week, if you have any questions, please let myself or Alex know in the chat. We'll be more than happy to address any of those as the session goes on. But right now, I'll pass it over to Alex. Go for it.
Perfect. Thank you for that, Nigel. All right. So like Nigel mentioned, we are going to be talking about some updates inside of HSM. So again, it's been out for a couple months. Maybe some of you guys have noticed some of the updates. This is going to be a perfect time for you guys to let us know what you think about it, right? Maybe you're not quite understanding exactly what that update does. Again, this is going to be a great chance. Feel free to ask questions. We'll make sure that we answer them along the way or towards the end of the webinar. But again, some goals for today, we want to make sure that we really express or really, focus on what the updates are and what they can do for you. Again, there was a few updates. For the most part, it is going to be focused on turning. Again, that's something that the HSM development team really wanted to focus on and enhance, in the meantime. But again, there are a few other things, and hopefully we can touch up on them. And then we are going to apply some of those updates to a demo part, and then that way we can walk through the workflow and see exactly how those updates look when you're using or programming a part. So like I mentioned, for the most part, it is going to be focused on turning. And the first one isn't really, too dramatic, I guess, if you will, but it's a slight warning that you get when you don't pick a Z-axis and you're doing a turning operation, obviously. Again, by default, usually it does, automatically know, or it's smart enough to pick up the center of rotation axis for your part. Again, sometimes you don't necessarily click on the correct model, or sometimes you have, other models that are visible or kind of out in your workspace. This is a great warning that allows you to really focus and make sure that you're selecting the right part when it comes to adding toolpaths, right? Again, it's trying to make it a little bit more efficient and user-friendly for the users. Again, you'll find this Z-axis warning in the original setup, right? So you can see this picture here. Again, you're going to start off your setup. By default, for the most part, you usually, like I said, if you're just working with the one-off part, you already have a Z-axis selected. Now, if you don't, again, you are going to get this no Z-axis, rotary axis selected warning box. Right. The next update was a WCS origins. So again, when it came to turning, you had limited selections when it came to selecting your WCS. Now, as soon as you hit the drop-down, you have a few more options that you can really play around with and kind of validate and test as you're programming some of these parts. And hopefully we can, walk through some of them and explain some of them as we're going along. And hopefully that makes a little bit more sense for you guys. The next one is going to be a safe Z. So again, it's just a renaming of the home position. Again, it's a little kind of counterintuitive, right, to some people. Some people really, this tends to throw them off. But the safe Z is really where your machine is going to do most of the change in tools, right? Now, if you have, let's say, a longer size tool, before that you were kind of just, stuck with the original safe Z position that you put. which is why now you have the option to override that save Z position. Again, if you're working with, let's say, like a 6-7 inch boring bar or a drill, you don't want to create or have any tool changes close to your part, because obviously you're going to run into some issues and possibly crash your machine. So luckily now you can override that safe Z position. And again, it just allows for more efficient programming, right? Because again, you want to make sure that your tool changes aren't too far away from your part. You're not really spending any time or wasting any time kind of traveling, from a far away home position to your part. Now you can override and keep that distance pretty minimal. The chamfer now has multiple passes. Again, before it was just a single pass, and if you wanted to make a pretty aggressive chamfer, it was going to be, a 60, 70 thou chamfer pass, which might be a little bit aggressive, right? It might not give you the nice finish that you look for in the chamfer. But now, luckily, now you can enable multiple passes and then specify what the chamfer depth is going to be for each one of those passes. And this is actually a pretty big one. We had a few customers a few months ago or a couple months ago kind of ask, for the parting edge break capabilities. So before you had to, kind of work around it, maybe do a tool path that dug into the part a little bit towards the end. But now you do have the ability to add a chamfer or even round off the edge when you're doing a parting tool path, right? So again, that's going to eliminate maybe some manual labor, or again, it's just going to eliminate another tool path that you have to create overall, right? So we're going to kind of dive into this one towards the end too of the webinar and show how that looks like. And then transitioning over, another pretty big update that they have is to the tool library. So now you can import tool libraries from additional vendors, right? So this has kind of been in the works for a long time coming now. Now you can go into the Autodesk HSM website, and you have the ability to download from multiple vendors. So hopefully in the future they are going to try to expand on this list. But for right now, they do have just what's there available for you. And again, we're going to walk you guys through how to download some of these tool libraries and import them into your own tool libraries. All right, so now we're actually going to go into a part. We're going to program it, add a few tool paths, and highlight some of the updates that Autodesk implemented into HSM. All right, so right off the bat, again, we're in Inventor, right? Again, we're working with Inventor HSM. As soon as we open this up, for the most part, you're going to do either do some of the modeling in here. Maybe a customer imports a part, or they send you they're going to send you some sort of a part. You can export it into Inventor. And here again, you can do some direct edit modeling if you wish, or make some slight changes to the model, if they want you to do that. But nonetheless, once you add HSM, or once you download the HSM add-in, you're going to have this little tab on the top, right? So the CAM tab, and here we can see that the workflow kind of changed. Some of the commands are now more introspective into the CAM machining toolpaths. One thing that I don't really like is the way that this is in the very first position, right? So typically what I like doing is I just like to drag this over here. I like to bring it right after the cutting ribbon here. And reason for that is because, again, I like to follow a left to right workflow. Again, I like to add my tool paths, right? So start off with the setup, add tool paths, and then kind of work my way down to the simulation, and then finally post-process, right? So I like to see this as kind of a finish line. And that's why I like to keep this specific panel, somewhere towards the end here. But anyways, when we're starting off, with our original setup, we're gonna have this other little CAM tab up here. And in here, this is where you're gonna start creating your setups, add toolpaths. Again, it's nice that it's it's split up or divided into your model workflow and your CAM workflow over here on the left. So again, first things first, let's go ahead and start off with our setup. You do want to make sure that you change that operation type to turning, right? So in this case, change that to turning. Again, if we didn't, let's say we had a few parts here, right? If we were to just go ahead and click OK, notice that we get that Z-axis not selected warning, right? So let's go ahead and edit that setup. So now notice that it automatically picks that for me. And in here, again, you have a few other options, right? So now you can actually dictate where your x-axis is going to be at. In the past, you weren't really able to switch back and forth between model and cam. Now, if you want to go to the model tab, maybe you have a specific axis that you want to follow, right? Now you have the ability to expand your origin and really make selections off of the model workflow that you have here. But anyways, for this part, I'm going to leave it as is right now. For the stock, notice that you can change a few things, right? So we have diameter of 2.5, which I'm okay with, length of 8.5, and notice that again by default it's going to position it in the center of the stock, right? In this case, I don't want to remove all this material until I start actually creating profiles, so I'll do a slight offset from the front, and let's say in this case I just want to do just enough to face off the part and get a nice nice clean surface over here on the front of it. After this, go ahead and click OK. Right, and again, it's giving you that warning because it doesn't get selected. So once you go back into the setup, you want to make sure that you do click on that Z-axis rotary, right? So clear that out. Click on the Z-axis rotary there, and then here inside the setup, you have the other options, right? So you have the safe Z. Where do you want the safe Z reference to be from? Do you want it to be from the stock front, from your WCS origin? In this case, I'll probably want to make it from the front of the stock and just increase that slightly, right? Maybe 1/4 of an inch. We don't want to be too far away from the part there. And again, you want to make sure that you do select the model and then spun profile, right? So I'll leave this unchecked for now, just to kind of walk through an issue that a lot of our customers go through. So then after this, everything's looking pretty good. Just go ahead and click OK. Now, similar to your milling operations, right, or to a milling workflow, the first step is going to be some sort of a facing operation. Again, we're going to be working with the turning panel over here. So click on face. And then we have this nice little workflow here, right? So again, these 5 tabs are always going to be the same for, turning a profile apart, even grooving toolpaths. This workflow is always going to be consistent. And you're always going to have the same tabs here in order, right? So again, starting off with the tool, then selecting, your geometry, the radii. So instead of heights, now we're actually working in terms of, some sort of radius here. The passes tab, again, controlling how aggressive you want to be with your passes. And then, of course, the last tab is the linking tab, right? So how it's going to retract, how it's going to lead into your cuts, and all that good stuff. This is where you would control that. So again, first step is selecting the tool. In this case, I probably want to use this CNMT. Now, the nice thing about the facing toolpath, it's similar to the milling facing toolpath, is that you can just select your tool, click OK, and it automatically creates that toolpath, right? So it's smart enough to know the front of the stock and the front of the part, and it creates the toolpath accordingly there. Now, what I can do after this is, again, do some sort of profile or roughing operation over here on the outside of the part. Now, if I go to do a profile, again, the software is going to be smart enough to select my tool. I can just go ahead and click OK, right? Click OK, and it gives me an error. It actually doesn't even give me a toolpath, right? Reason being is if you guys want to look into the error, by the way, you can expand this, right-click on None, and then go to Show Log. So here's a little error message, right? So it's saying turning profile is split into 2 or more closed parts. Well, what exactly is that referring to, right? A good indication is this little highlighted region, right? That's kind of shaded in yellow. So we can see that there actually is some sort of a gap in here, right? Or the software is picking that up as a gap. And that's where the toolpath is essentially failing in this case, right? Now, the way to get rid of that error is if you go back into your setup, and this time you do want to go ahead and check spun profile, right? So this is a good option whenever you have some sort of a gap, or you have through holes through your part, and you're doing some sort of turning operations and you get that error. This is always going to be or it should be your first go-to option to check on, right? So check on spun profile, go ahead and click OK. Again, and there's been a change to the setup, so you want to make sure that you regenerate your toolpaths. You can right-click, generate toolpath. So now there's our facing operation, and then now we actually did, in fact, generate some sort of profile, right? It's not what I want though. Reason being is that it's machining, over here in the front. It's kind of grooving into my grooves here a little bit. So let's go ahead and edit this just one more time. So the first thing that I want to change is this grooving option. I'm not going to allow grooving for this operation. The next option that I'm going to allow is the rest machining, right? So I want it to pick up the previous operation, the facing operation, and stay away from that face over here in front. And what I would probably do too is extend the profile just a little bit, just enough so that I have enough, enough room or a nice surface to come in with the parting tool and part this, part the part once you're ready to, cut it off. So in this case, what I probably want to do is go back maybe 130 thousandths. Again, this is going to be a roughing operation, so I don't want any finishing passes. And from there, really just go ahead and click OK. Right, so that toolpath is looking much better at this point. Again, maybe you want to do some sort of finishing pass on the outside, right? Again, if it was a roughing operation, you want to make sure that you leave some sort of stock, right? So in this case, again, you're going back to the toolpath, back to passes, and then enable, some sort of stock to leave here. In this case, let's say 10 thousandths. And there's our toolpath. Right, so now instead of going back over here to the top, creating another profile, another finishing pass, I can just duplicate that toolpath, right? Again, I want to use the same commands, the same, maybe not the same tool, but the same geometry, same feeds and speeds, and everything from the previous toolpath, right? So again, creating the same toolpath. This time though, what we're going to change is now we're going to use a different tool, right? Selecting that. From previous operations, we still wanted to look at that previous operation. And then in this case, we want to turn off roughing passes, right? And then change stock to leave. Right, so in doing that, we can have one nice finished pass along the entire part. And that's going to give us a nice surface finish on the outside of the part here, right? So again, pretty straightforward part. We're kind of working our way through it here. Really, the last operations would probably be some sort of a grooving toolpath and then parting off. And then that would probably be it for this part. So again, let's go ahead and do the grooves here. Again, a lot of people would probably select that grooving toolpath. I would probably hold off on that. And reason being is, again, we only have a single groove here, right? So we have single grooves along the part here. Now, what I like doing is, for the most part, is just selecting the groove tool that I have, right? In this case, luckily, I do have a tool that's the same width as the groove cut here. But if not, if for whatever reason it was a little different or it was a little off, you can go into the grooving toolpath. But in my case, I can go ahead and do single groove and make sure that it is the correct tool here. There we go. Now, for the single groove tool, you want to be careful with your selections, right? So first off, you do want to make sure that you select them in order because, again, it's going to kind of follow the order that you select. And you also want to make sure that you select, similar to a 2D contour in the milling toolpaths, you want to select the bottom of that groove, right? So you want to select this edge here, this one here, and then that one on the edge there. Right. Okay. So now notice that it's not really aligned to the end of the groove there. So you want to change that to front because, again, that's going to be where the front of the tool is going to essentially hit or be at. And again, we pick the bottom of the groove, so it's smart enough to know, okay, that's going to be where the bottom, the surface is going to be at for the specific part. We can go ahead and click OK. And really the last step is going to be a parting toolpath. But one thing I actually did forget to kind of touch on is if we go back to the face toolpath, click on edit, you actually do have the option now to cross the rotary axis, right? So what I mean by that is before you didn't have the option to kind of go slightly past the center of the part. So what that would do sometimes is maybe create like a little nipple at the end of the part, right? Again, not a big deal, but if you're making parts that are that need to be cosmetically correct, or maybe you want a nice clean flat surface, that was going to present some issues, right? So now if you go to the radii tab, if you go to the inner radius portion, you have the stock ID, right, which is what we would expect. So the inner radius would essentially be 0 in this case. You have the inner radius offset, and then you have this other option, right? So I don't believe this was included in the update. I think this was prior to that. But again, a lot of people kind of go through that and they don't really, they forget that they have this option now. So again, you have this option, distance to cut below inner radius. In this case, you want to go ahead and say you want to go below 20 thousandths, right? So it's going to be a little hard to see. In this case, if you do want to make sure, you can kind of make a drastic change there. But again, it's a nice little feature to have. And now, you're going to ensure that you're actually going past the center of the part and making sure that you do have a nice clean surface there at the front. So we can go ahead and hit OK. Again, the previous the rest machining toolpaths are always going to error out or ask you to regenerate, because again, it's linking or it's referencing the previous operations over here, right? So again, generate toolpath, and we're good to go there. All right, so the last step here will probably be to part off. So again, it's pretty simple parting tool. You're going to be using that same 1/8 inch parting tool or groove tool that we had. And then this is where you have the option to do an edge break, right? So we can turn on the edge break here. We can say, all right, we just want, just a small edge break, 50 thousandths it's gonna be it for me. And then the radii tab, right? So you want to be careful with this a little bit, because again, it's referencing the chamfer is actually referencing your radius that you have specified in here, right? So in this case, I want to say, I want to do the model OD 0.1. Again, I want to probably do model OD and then probably say, again, 0.2 for this one, right? And then, again, referencing the outside of the model here, probably say 0.1. And then click OK, right? So again, nice little feature to have, and you can verify that it actually is creating a slight chamfer here by the difference in shading, right? That's a good indication that the toolpath is going to be cutting through the part. So again, we don't have the chamfer modeled, and that's not always necessary. Again, you can drive the toolpath based off of some of the settings that you create. You are going to have to kind of play around with the with the settings there for the radius though. So now, really the last step before you post out is you want to make sure that you simulate what you have out so far, right? So hit simulate, hit play. I don't know how well that's going to transfer over through the webinar there, but again, we can speed it up. Go to the very end here, and then that gives us kind of your finished product, right? What's nice about this too is that now you can do a show part comparison, right? So we click on show part comparison. It gives you kind of a nice shading of what still needs to be, worked on and what's been machined out. Right? So really nice feature here. I would definitely recommend people to take advantage of it. I often get questions on, these two parameters or these two values. That's really just referencing how granular you want to get with your I guess with the coloring here. You can go pretty high up, but again, that's going to take a little bit longer to generate. So really, I often find that the default values are going to be good enough for for a good part comparison here. Now again, we can't really see the chamfer here. Another trick that I like to do is I like to go into the model tab and I like to just turn off visibility when I'm simulating, right? So then that does get rid of the part. But being that we already have our stock defined, we already have our toolpaths created, this is really going to give you a nice representation of what your toolpaths have created. So again, I'm going to turn off part comparison for this one, go to the very end, and now we actually see that we have a nice little chamfer here at the end. Right? So again, pretty straightforward webinar, but again, hopefully we touched enough on some of the updates. Which, by the way, I don't have any holes or any holes going through the center axis here of the part or any drilled operations. But really, let's say for whatever reason, we wanted to do this single groove. and override the safe Z for this one, right? Again, that's going to be found under the linking tab. Now, if you go to approach and retract, now you have a few options here, right? So now you can override the setup safe Z. So now instead of being a 1/4 inch away from the part, now we can kind of increase that a little bit and then have a safe, a safe tool change somewhere out further away from the part, right? And again, that's going to allow for more efficient programming. You want to be as close to the part as possible when you're doing any tool changes or any work, and then that way the machine can get pretty quickly back in here and machine the rest of your part, right? So again, pretty straightforward webinar, but again, hopefully we touched on some important updates here. So at this point, I guess we can open it up to questions. I don't know if there's any questions that came along the way, but this is our contact info, right? So if you guys, again, maybe down the line you have a few questions with anything Inventor, Autodesk, HSM related, feel free to email us, either Nigel or myself, and we'll definitely get back to you guys.
Yeah, if it's HSM related, Alex probably better bet than myself. But yeah, feel free to send us any questions you do have in the future. For those of you who are watching this, post webinar. But for those of you who are online right now, go ahead and type your questions into the GoToWebinar chat panel or your whichever streaming service you're using to watch this. I know we have multiple now, and you can type your questions in there. So let's see here. Alex, is there any documentation on what's in HSM? So I guess release notes is what they're asking for.
Yeah, absolutely. Yeah. So if you go, I believe if you just type up the, and that's one thing I also didn't mention on the tool library. But if you do what's new in HSM, release notes, right? So we do have release notes in here. You can go to the what's new, and then they'll kind of outline, some of the new features and changes that they've done.
Yep, and they update that web page with like all the release notes for every release for both Inventor HSM and for Fusion as well. I believe.
Absolutely.
So
yeah. So while we're on here, this just reminded me that we didn't touch on the tools here, but it's pretty straightforward. Again, if you guys want to go ahead and kind of go through some of these options, this is going to be a great catalog to kind of download, right? Especially if you're big on some of these vendors here. Look through it. This is going to be the URL here that you want to follow or you want to go to. cam.autodesk.com/HSM tools, right? So again, that's going to take you to this web page. From here, you can go ahead and select one of your vendors. You want to make sure that for our case, we are using Inventor HSM, so you want to download the Autodesk HSM tool library. Go back into your CAM workspace, right? And again, you want to go to your tool library over here in the Manage panel. Under My Libraries, you want to go ahead and do a new library, and let's say we can just call it ABA. Now, what you want to do from here is right-click, import tools from library. And notice that you want to navigate kind of to where you downloaded it to. In this case, it's going to be my downloads folder. Then go to the Harvey tools, click open, and it automatically brings in all of our tools, right? Now, a couple caveats to this is that it doesn't have the feeds and speeds associated with those tools, right? So that's something that you still have to go in there and make an edit to. What's nice about this, though, is if we go, let's say, Harvey tool, let's say we want to, we go through the catalog. Maybe we want this 1/8 inch, maybe 1/4 inch. Let's say we want this one right here, right? So we can download or copy the product ID here, go back into Inventor, paste that, and it automatically brings up the tool that, that's going to be listed, right? So it's going to have the correct geometry, the cutter diameter, the flute length, the shaft length, everything is going to be correct. The only thing that you do have to change is going to be the feeds and speeds here. All right, so that's one thing that you kind of want to be cautious of. But again, everything else is already set up for you. If you go to the General tab, it has a nice description, vendor, the product ID. So it's very nice, and that's definitely something that I recommend you guys take advantage of.
Yep. And then make, I guess, a custom library from that library, the tools you actually own? Because I'm
Yeah.
assuming most people don't own all couple hundred, if not thousand tools, right?
Yeah, I know. And if you are one of those, I mean, that's, all props to you. But yeah, from here, go ahead and create a new library and then just kind of drag and drop, the tools that you do have into those custom libraries. But yeah, that's one of the new updates that Autodesk has for HSM.
Yeah, that makes it really easy. I know I've seen Alex model tools in the past, and now you don't have to do that for at least a portion of the tools.
Yeah,
that's
absolutely.
Good. All right, we got a question from Brittany. Will smaller boring tools be added for inside diameters?
Yeah, so that's actually a pretty good question. I'm not sure if they have the round boring bars implemented into HSM yet. I know Fusion 360 has that. I have to double check for HSM, but what a lot of people do is they don't model the boring bar. They just do the insert, right? Again, it is a lot of risk with that because you're not seeing exactly what's happening with the boring bar. But you can, if you go to the inserts, let's say you're going into the let's see, turning sample tools, clear that off. Yeah, so if you go to edit, you can change the some of the parameters in here, right? So again, depending on what tool manufacturer you're using, sometimes they have a catalog of all these values. Go ahead and change those values and match whatever you have. So you can go pretty in depth with these. And again, sometimes you might have to maybe change the holder style or the holder setup, holder geometry, in order to get the correct simulation. Awesome. Yeah, so that would be one way.
Cool. And then another question, Alex, for post processors, running custom post processors, what's the best way to do that? Do we have any material on that, or? Yeah, so there's tons of material online. I believe there's even a few guides that kind of walk you through the most important sections of the post process. That's something that we do in house as well, right? So if you do want maybe some guidance or you want some post modifications, we do that in house as well. And that's like I said, we can walk you through whether you want to learn how to do that or just get it done. That's something that we can definitely accommodate for. Yeah, and that'll be Alex, not myself. Yeah, a few of us here. Again, it's the posts are written in JavaScript, so it's not terrible when it comes to editing or making modifications to the post. But again, some slight programming background might be a little necessary for that. That'll be super helpful. I've looked at a little bit of it. I can understand a decent amount of it, but once Alex gets into the weeds there, no, like Alex is your guy for sure. Let's see what else we got here. Do you need Inventor 19 to run this version of HSM? Yeah. You need Inventor 2019, but I don't think you need an Inventor update. So as long as you're installing on top of Inventor 2019, you're fine. But you don't need to be like 19.2. Yeah, so what I think you can do is you can't have Inventor 18 and HSM 19. Yeah, so I think that there might be some compatibility issues there. But yeah, you can run Inventor 19 and then have HSM 2019 or previous versions of HSM as well. That's so yeah, just make sure that your Inventor and your HSM, the whatever number is attached to the other that matches, right? So 1919, 1818. 1717. Same thing goes for Nastran and CAD and a lot of the other add-ins. Just make sure that the add-in is compatible with the version of Inventor that you're using. That's a big one, especially when people are trying to start using things like Nastran and stuff. So if you have any questions on compatibility, let us know. We can help you find that information. It's all out there, and we can help you find it. All right, I'm gonna give everyone another 30 seconds or so to ask any more questions that they do have. Let's see here. Let us know too, by the way, guys. At the end of the webinar, there, what do you guys want to see? Next on HSM. I'm pretty comfortable doing a different variety of topics for HSM. So let us know what you want to see. Do you want to see maybe fourth axis milling? You want to see a little bit more turning? Let us know what topics exactly to create next for HSM. There's another question here from Brittany. cycle machining times, are those calculated and are material properties factored in?
No, they're not. Yeah, so the cycle machining times are calculated, but in terms of taking into account the material properties, it doesn't do that. So again, one good way to check cycle machining time is if you go to simulate. Again, I clicked on the entire setup there, and that encompasses all the toolpaths that I have. If you go to info, it should have the cycle machining time in there, right? So it kind of tells you here, 0.43. If you go statistics, tell you machining time here as well, right? Yeah, so info tells you that specific tool operation, and then statistics tells you the overall machining time. Yeah, but it doesn't. Yeah, your feeds and speeds don't take into account the whatever material you have selected, right? So that's something that you do have to input manually and do some testing on when it comes to testing out some of these toolpaths.
Awesome, cool. I think that's it for questions, Alex. Again, thank you for being here today.
Yeah, thanks for
and doing some HSM stuff for us. If you guys have any suggestions for what Alex should do next, let us know. He might have done it already. We can send you that webinar, or we'll go ahead and plan for that in the future, regardless if it's HSM or not, right? So if you want to learn more about, say, for example, thermal simulation, you can show up next week and see that. So that's not going to be with Alex. I'll be with one of our good friends here, Nikhil Venkat. It's going to go over some thermal. Yeah. All right, cool. So it looks like some people are already sending some stuff in. We'll follow up and make sure that we get that squared away. Thanks, everybody, for your comments. Again, thanks, everyone, for joining us today for Autodesk Virtual Academy here with us from Katif Technologies. We'll see you again next week at 10 a.m. on Thursday. Thanks. Have a great weekend, everyone. Bye.